Hi, good morning. Happy Sunday. Before I start with the Apache Spark Declarative Pipelines, I have a question for you. Are you still building the production data pipelines the traditional way in Spark? I know you are, right? To be honest, it's exhausting, right? You know exactly what I am talking about. You are completely drowning in boilerplate code. You are constantly babysitting your orchestration, manually wrestling with your schema drifting, and honestly, spending half your week just trying to fix the broken dependencies. It feels like you are spending more time maintaining the pipelines than the actual building valuable data assets. But look, what if you did not have to do any of that? What if you could build production grade incremental pipelines on Databricks by simply declaring what your data should look like and letting the platform handle all the heavy lifting? That will look cool, no? Absolutely. No endless lines of infrastructure code, just clean declarative pipelines for the data engineering work. This is exactly what we are mastering today, and this was introduced by Databricks in June 2025, and I am betting that this will be booming by 2027. Welcome to the ultimate guide to Databricks declarative pipelines, or you can say Spark declarative pipelines using Delta Live tables. Now, this is not just another high level overview or a quick feature demo. Over the next 2.5 hours, we are diving deep into a full scale masterclass. We will just not cover the theoretical stuff, we will also be going to build a robust production ready pipelines framework that also completely from scratch. And the best part is, we are doing absolutely everything in both SQL as well as in Python because I know my community. Else, some of you will be saying, Jaswinder, we are Snowflake people, we don't know Python. Or Jaswinder, we are data analyst. Or Jaswinder, we are ETL developer. Or Jaswinder, we are Databricks person, blah, blah, blah. A lot of things you guys will say. So I know my community and I need to handle all the kind of audience, which makes me think twice that I need to create the Databricks declarative pipeline tutorial using SQL as well as Python so that I am helping both Pythonic and non-Pythonic persons in my community. So no matter what your tech stack will look like or what your team prefer, you are completely covered. By the time you finish this masterclass, your workflow is going to look completely different. You are going to know exactly how to automate your architecture by effortlessly transforming your raw chaotic data into polished production grade bronze, silver, and gold lake house framework. How you can lock down the data quality by implementing the strict data quality expectations to catch and quarantine the bad data before it even touches your production environment. And you will be also deploying the applications like a pro. Look, this is an intensive deep dive session. If you look at the syllabus on your screen, you will see exactly the depth we are hitting for both SQL as well as for Python workflows. We will be starting with the problem statement, what is SDP, and before SDP, what was there, how DLT got introduced, and why Databricks decided to make DLT from their premium service to open source. Then we will be discussing about the flows, then datasets and pipelines, and we will be covering all the hands-on on streaming, materialized and temporary views. Then we will be working with both SQL as well as Python, and we will be implementing SCDs and append flow within seconds. We will also be seeing lineage and syncs, and then we will be looking the expectations, which is very, very important. And at last, we will be also looking how we can schedule all of these things using Databricks provided jobs. So you can literally see now that I have broken the entire video down into a clean topic by topic chapter so you can easily understand step by step and build along with me. All the codes are uploaded on my GitHub. Any doubts, you can comment below. I will answer your comment. Or you can ping me on Telegram, or if you want, you can even book a free one-on-one session with me on TopMate. So grab your coffee, open your Databricks workspace, and let's change the way of building the data pipelines. Now it's the time to discuss about the latest Spark Declarative Pipelines, and this is coming to boom since Spark 4.1, and I am 100% sure that by 2027 this will be every company's preference. This is actually creating revolution in the Databricks environment. And even it's a open source, you can understand how big the impact will be. So definitely this is a revolutionary announcement which Databricks made in June 2025. Trust me guys, when you work with this Spark declarative pipelines, it is very easy and convenient to maintain the CDCs, to even implement the SCDs. If I say you that you need to implement SCD type 2, you will literally have to write at least 400 or 300 lines of code to implement the SCD type 2. But here we have a complete template to manage the SCD type 1 and type 2, and it is hardly of 7 or 8 lines. And that's why it is a revolutionary invention of Databricks, and it is definitely going to be the boom by 2027 or 2028. Mostly by 2027, because already it is point of conversation and companies started understanding these things, and in future you will be seeing this thing in the job descriptions as well, that we require a person who have hands-on experience on Spark declarative pipelines. This something which definitely you have to learn, and once you learn this you will be ahead of 95% of other persons, and you will definitely get prioritized when you had mentioned the Spark declarative pipelines in your resume. Interviewer will be very impressed and you definitely gonna crack that job. But as it's me, it's Jaswinder, I literally don't go directly what is Spark declarative pipelines. I always prefer to help you with the problem statement, the evolutions which was happening and everything, right? So yeah, here also I will do the same thing. So first thing, I will help you understand what exactly the need of Spark declarative pipelines, why it was invented, and why Databricks is so much pushing this new framework. Okay. So what happened? This is the Databricks architecture. If I say more precisely, this is the Databricks architecture back in 2021 or 2020 or 2021. Okay, anything. You need to handle all the operational governance and the quality things on your own. It was a challenge, right? Because you need to spend ample amount of time in doing these things instead of directly going and jumping and getting your work done. This is where in 2021 Databricks introduced Delta Live Tables. What they said is that it will enable all the data engineers to streamline and democratize their ETL jobs, and it actually makes the ETL life cycle very easier, and it enables all the data engineers to build and leverage their own data pipelines by directly building the production ETL pipelines. They are very happy because they don't need to take care of any kind of operational governance and any kind of quality challenges. So by introducing this DLT, Databricks said that please just focus on this part, which I am just highlighting. So Databricks said that please focus on this part. All the other things I will take care of you. You don't need to spend your time here. This concept they name is Delta Live Tables, and these are not the tables. This is a framework which they introduced in May 2021, and this was a revolutionary framework because now lineage, operational things, governance, quality, I can literally leave these things to Databricks. Databricks had provided me some very quick functions in DLT library. So all I just need to focus was I just need to write the code either in SQL or in your PySpark, and you are done and dusted. And it was publicly available in June 2022. Since the time it was available, every everybody started using Delta Live Table framework, and it actually helped a lot of companies in fast pacing their project deliverables. So now let's understand the Delta Live Tables definition as well. Delta Live Tables is a declarative framework. Yes, it it is not a vast thing. It is still there. Okay, it is just evolved, but it is still there. So Delta Live Table is a declarative framework on Databricks that simplifies the building, testing, and managing of data pipelines. Instead of writing complex script to orchestrate data, you simply define what data transformation you want using either SQL or Python, and DLT will automatically handles the infrastructure scheduling and any kind of error recoveries. So this fast paced the development in June 2022 when it was publicly available. A lot of good things was happening at that time, and it was very revolutionary. So let's talk about the key features. The first feature is its declarative pipeline design. You can declare the target state of your data and the framework automatically, which can track all the dependencies and even helps you in resolving them. And second is automated operations. It automatically manages all the cluster scaling, task orchestrations, error handling, and any kind of retries. So you don't need to care more about the operational perspective as well. The third is data quality, which we had already discussed. If your rule is failing, you can literally ask DLT to handle that thing. You can say, DLT, if my rule is failing, just give me warning, or just fail it out, or let's say just drop it, or anything you can do. You have now complete flexibility. The fourth one is batch and streaming. And obviously, it natively supports the streaming data and batch processing. By streaming data, I means obviously micro batches, right? And it allows you to use the exact same logic for both of kind of batch as well as the streaming processing of data. So when you have to create the Delta Live tables, all you need to do is you need to mention create live table, and then you need to mention all your SQL if you are working with SQL. And if you are working with the Python, you need to import the DLT library, and then you can just use and get your work done. Here also you can see the clear example that this is how you define the live table pipelines. You don't need to worry about any operational infrastructure thing, any testing scenarios. Everything Delta Live Table framework will handle for you. So Jaswinder, we are clear with Delta Live Tables. We understood that it was a revolutionary thing, and Databricks introduced this thing in 2021, and since 2022 everybody started loving this thing. We understood this thing. Then why you mentioned the evolution? The thing is, guys, Databricks obviously introduced the DLT, but they introduced DLT as their proprietary closed source abstraction layer. This means you can only use DLT when you are having actually the Databricks subscription or additions. This was totally isolated within the Databricks. Okay, so let's say there is a company who had worked on all these DLT things, and they had definitely built everything out in the Databricks. Now they decided, due to XYZ reason, they decided to move out of Databricks and go open source with Spark. You know what will happen in this case? Because this is the proprietary framework of Databricks, you cannot directly move out of the Databricks, because DLT relies on custom Databricks APIs and all the decorators like import DLT. That was also the custom Databricks API. If you try to run this on Apache Spark, the code would immediately fail with the module not found error, because DLT module was not existing in Apache Spark, right? It was only existing within the Databricks environment. If you have to migrate it, you need to redefine your codes, because DLT library does not exist there. There is no concept of live table. You obviously need to reinvent the wheel, right? The second problem was complete loss of orchestration engine. Here in DLT, you just write your codes and automatically DLT framework ensures that your code are having a coordination between the workflows. So let's say you had a code in the row table and then you had written the code using the row table for the bronze layer. It will automatically detect that the row table is referenced in the bronze layer. So this means row table should be first and then the DAG will be having bronze layer. So this was automatically detected by DLT and this is still automatically detected, but things little bit change, I mean little bit got more advanced, more helpful. Okay, but yeah, coming to the point, it was a complete loss of orchestration engine because you first is reinventing the wheel, and when you reinvent the wheel and you are now open source, you again need to define the orchestration things on your own. And obviously guys, if you remember, we used to use Airflow and ADFs. If you remember, even before DLT, if you have to schedule these things, people prefer ADF and Airflow and any other orchestration tools, right? That was the second major problem. The third major problem was the data quality rules. The thing was, DLT allowed developers to easily declare the data quality checks using simple configurations. Okay. And there we had a configuration like expectations. Okay. We have a configuration term in DLT which we call expectations. Okay. Don't worry, we will cover that out. But you just know that open source Spark have no native thing which can help you automatically declare the data quality frameworks. So if you have to leave the Databricks back in 2022 to 2025, something in these 3-4 years, engineers have to manually build the custom validation functions using Spark native commands, or you need to integrate with the third party libraries like Great Expectation Library. Okay. And then the fourth biggest challenge was you need to rewrite the incremental ingestion of CDC, because features like SCD or handling CDC were built in DLT by the Databricks team. Okay. And it was provided to you as a simple declarative commands. But now you decided to move out of the Databricks. You need to replicate this in the open source Spark, which requires writing extensive boilerplate code like merge into or implementing your SCDs, and you need to manually manage all these streaming checkpoints. Can you understand the pain if you want to move out of Databricks at that time? So a lot of engineers was complaining that, hey Databricks, we are implementing the things in DLT. We love DLT. There is no problem. There is no doubt in our love. But if we want to go open source due to XYZ reason, we cannot have DLT there. So that's the pain for us. We need to reinvent the wheel. Please help us. Then Databricks decided in June 2025 to make the DLT as an open source framework. So in June 2025 in Databricks AI Summit, they announced that moving further, DLT will be an open source framework for everybody on this in whole world. When they made the DLT as an open source framework, that was a very, very big relief for a lot of data engineers, because some people really love to go using open source Apache Spark. I mean, even till now, many people use open source Apache Spark to get their things. Being DLT as a open source in the picture was a very, very big relief for everybody. Then once it gone open source, then Spark team, obviously Spark and Databricks was invented by the same team. Then Spark team added a few additional features and they named this DLT as Spark Declarative Pipelines. And that was the birth of Spark Declarative Pipelines. I guess it should be crystal clear to now what I had said till this moment. This is the time which gave birth to Spark Declarative Pipelines, or you also can say LakeFlow Databricks Declarative Pipelines. Some people say Databricks Declarative Pipelines. Anything is fine. Anything is fine. And again, this is open source. So open source give a lot of flexibility to the developers, right? So that's how Databricks evolved from 2021 to 2025, and now in 2026, Databricks declarative pipelines are the priority for most of the companies because it is minimizing my excessive overheads and it requires my data engineers to focus purely on the development part. That's why I had said in initial minutes that Spark declarative pipelines will be the future of data engineers. By 2027, this will be seen in the job descriptions as well. And this is already being seen in couple of companies' job descriptions. You can go to LinkedIn and you can see the Databricks jobs, and they are demanding this Spark declarative pipelines because it is now getting mature. So by 2027, I can literally bet that there will be very limited companies which won't be having Spark declarative pipelines in their JDs. That's the motivation for you guys to master this Spark declarative pipelines for Apache Spark 4.0. Okay, let me write this here. Apache Spark 4.1, not 4.0, 4.1. So this is the latest 4.1, and we will be focusing on this one. And by the way, this Spark declarative pipelines are not part of your examination. So as I initially mentioned that this complete course is your job ready plus examination ready plus to enable you for being a project ready person. So everything under a single place, right? So yeah, I am very excited to share all these things with you because as of now I'm recording it. So once I share it, I really want to get your feedbacks. I really want your blessings here. And please do like and subscribe to my channel. Now let's focus back and let's understand the Spark declarative pipeline definition. And if I just print it on your screen, you can literally see that it is very similar to DLT framework definition. Let's read this. Spark Declarative Pipelines is a framework built for Apache Spark that shifts data engineering from writing manual step-by-step scripts to simply declaring what data sets you want. So Spark Declarative Pipelines focus on what instead of how. You just need to work on what when you are working with Spark declarative pipelines. How these things will work, that's not your headache. That's Databricks headache. It automatically figures out the execution order, orchestrates all the dependencies, and handles the incremental data processing. And when I will show you this thing, guys, you gonna love this because if you had worked with any kind of SCDs, you know how much effort it take. And I am telling you in advance that I will create a SCD type 1 and type 2 for you within a minute. A minute, yes, that's the revolution, guys. Cool. Let's now discuss about the key components present in Apache Spark declarative pipelines. First is flows. Flows are nothing just a way where you define your logic and it creates a complete connection between the source and load the complete data with the process to the output tables. So this focus on what you want to do with transformation, and obviously the how part will be taken care by Spark declarative pipelines. So flow is a foundational stateful unit of computation. It reads data from sources, process it through user defined logic and writes it to the target. Okay. This whole reading the thing, processing it and writing it is nothing just the flow in Spark declarative pipelines. Cool. So as we just discussed, it focus on what data to transform and how and that frameworks, all those things are managed by Spark. This is known as flows. Next is datasets. Datasets are the target objects which is generated by the flows. So you have a data in source, obviously you process the data and there is a target which is formed with your flow, right? So that target object, we can call it as a data set because that target is stored somewhere in your Databricks, right? So this is known as dataset in context of Spark. Let's go with the definition. In Spark Declarative Pipelines, datasets are not just temporary in-memory objects, but are persistent managed entities that define the state and structure of your data infrastructure. So simply they are just saying that it is a target object which defines the state and infrastructure of your data, right? Because in target table, you have a complete structure, the state of the columns and all those information. So now we can have a flows stored with the three ways, okay, in the data sets. So that we call supported dataset types. Spark Declarative Pipelines have the three abstraction types which can manage the data sets. The first is streaming data, and that's self-explanatory that we are consuming the data incrementally as the micro batches and we are appending the stream to the data set. Second is materialized view. This is the view which pre-computes your results and it automatically updates any incremental changes happening to your data. Okay, so it is best for complex transformations, joins, or aggregations. The engine pre-computes the query results. That's important to note. Materialized views stores the pre-computed results, okay, and automatically updates them incrementally when underlying data changes. Make sense? Cool. And third one is temporary view. Temporary views are just for holding the query and compute the results whenever there is a requirement to run the specific script. So obviously they are again reusable, but they are kept private in the pipeline and they are not exposed directly to the final data catalogs. So this is all about datasets. So flow is a process that how you are getting the data from sources, how you are processing it, and how you are writing it into a target. And the datasets are the persistent storage objects which defines the state and infrastructure of the data. And then we had seen the type of ways where you can store the flows like streaming tables, materialized views, and temporary views. There is one more component which is pipelines. And I guess you know what are pipelines, right? But still it is basically a DAG of all the components, right? So by components, I mean DAG which can contain one or more flows, right? And flows can be streaming tables, materialized views, correct? So it's just a process of encapsulating one or more flows in a single process which basically forms a DAG. Let's now jump to the Databricks. I hope till the point you have your Databricks Community Edition, which is obviously free. If you don't have, just type Databricks Free Edition and then you will be redirected to this Databricks website. And here just click on sign up for free edition and create your account here. Cool. Now, once you log in into your Databricks workspace, this is how it will looks like. They are providing a learning section as well for the data engineers. That's really commendable. Then we have a workspace. Workspace already you know what is workspace. And then catalogs and jobs and pipelines. And this is where we will be creating our Spark Declarative Pipelines. So as of now, I will just move. And then obviously in the free edition, the compute we will be having serverless. That's okay. And then we have marketplace and other couple of options, right? So it's a lot. Now let's first go to workspace and let's create a folder. That's the best practice. So the folder name, I will give it as SDP Pipelines. I will click on create. Perfect. My folder is created. Now I will go to catalog and I will create a catalog as well as schema. So I will say create a catalog and I will mention my catalog name as SDP YouTube demo. Yeah, everything looks good. Then I will just click on create. Yeah, then I will click on configure catalog. Yeah, and then all workspace have access. I will say that. And then I will grant the browse option as well, principal as all account users. And I will provide all the grants. Yes, grant. Then I don't have any external destination. I will just click on next. And then I will just click on save. And perfect. I had created my SDP YouTube demo catalog. And now let me refresh this. And then inside this, I will create couple of schemas. First schema I will create is bronze. and then I will say create. Perfect. And then I will create two more schemas. I'll click on here. Second schema I will create is silver. Create. And third schema I will be creating is gold. Perfect. I will go to my bronze, and here I will create a table, and I will browse one CSV file and SDP underscore orders. Perfect. And the table name, I will give it as, let's say, row orders. Perfect. And then I will click on create table. My table is successfully created. Let's now also create the customers table. I will go to bronze, and then I will click on create and create a new table. I will click on browse, and I will just click on customers. And here I will name this as raw underscore customers. And yes, then I will click on create table. So we had successfully created bronze layer, gold layer, and silver layer. Plus we had also defined two tables in the bronze layer. Now let's go to jobs and pipelines. And this is the place where we will be creating our Spark Declarative Pipelines. In order to create your first Spark Declarative Pipelines, just click on this create option and click on this ETL pipeline option. And this will open a new window where you have a folder called transformation, and inside the transformation folder you have a dummy my transformation.py file which is empty. So first thing first, I will name this pipeline as SDP pipeline 1. Click enter. Before doing anything here, you also need to ensure that one property is enabled in your setting which is related to LakeFlow. For that, click on your user icon here, then click on settings, and then you go to developer, and here just search for LakeFlow. See guys, LakeFlow pipeline editor, and ensure the LakeFlow pipeline editor is enabled. If it is not enabled, then you won't be able to work and run these things. By default, it is enabled only, and even this account is new account, but ensure that it is not disabled. Okay. So let's go back to our LakeFlow instance. And yeah, and now first thing first, let me explain you a couple of things. This is where you select your catalogs and schemas. So I am selecting my catalog as SDP YouTube, and then I am selecting my schema as silver schema. This is the target schema where we need to select. Okay, this is not the source schema. So once is selected, it will show you the default root folder. And I don't want that I am directly creating this pipeline inside my username. So I had already created a folder, and here I will just click on move to root folder. Then this is the folder which I had created, SDP pipelines. And then I will click on move. In this way, it will automatically move everything from this instance to that specific folder. Okay. And if you try to move this one by one or in any way, you might miss a couple of things. So it is the best practice to go here and then move your root folder to the respective folders. So now we had selected our catalog name and our target schema name. And then here we have the option to compute, which is serverless compute. And then there are a couple of settings which I had shown you that, as you can see, now my pipeline will be created inside the SDP pipeline folder, right? And then we have a source code which will be there in the transformations, and all the other information is available here. So this is one thing. The second thing is you can run the pipeline from here. You can share the pipeline from here. You can schedule the pipeline from here. And then in the bottom side, you have three options. First is tables, then performance, and then pipeline graph. And when you click on this pipeline graph, you should always try to have first dry run for the pipeline. Okay, we will do that. Now let me go to my workspace again, and I will go to my users, and I will go to my SDP pipelines, and this is my pipeline, and I will try to rename this pipeline, and I will say my first pipeline. I will click on OK, and that's it. Now let's go back to jobs and pipelines. And here I will click on my SDP pipeline underscore 1. Then I will click on this edit pipeline. And first thing, I will connect my serverless server. And I will now try to do transformations on my bronze layer data, right? So I will create two files. First of all, let's go to my workspace and let's go to all files. And here I will delete this file, my transformations.file. I will say move to trash. And instead of this, I will create two files. First, I will create my SQL file. I will name this as silver customer orders.sql. And then I will create another file, which is my Python file, silver customer orders dot python dot py. Cool. So now I will show you how you can work with PySpark as well as with SQL, because I know my community. Some of you guys are from Snowflake background and some of you guys are from Python background. So I need to ensure that both type of audience can work with the Databricks, right? So the best way is that instead of just going with my PySpark notebooks, I should also create SQL files in parallel so that they can actually see and implement either of them. If you say that, Jaswinder, which you personally prefer, then I personally prefer Python, or you can say PySpark. But I am not totally biased on the PySpark because dynamics are changing very fast, and now every platform is giving the SQL compatibility so that even data analysts can work with their tools, right? So yeah, let's start with SQL. I will first create a materialized view. I will give a heading, materialized views. And you already know what are materialized views, right? Even though you are from a Databricks background, I had explained you. And if you are from Snowflake background, you are very much versed what are materialized views. So I don't need to explain you here. So yes, so let's create the materialized view. In order to create the materialized view in SQL, we write create or refresh. Then I will say materialized view. Then obviously I will say if not exist in order to ensure the item potency. Then I will give the name because I am going to create my materialized view in my silver schema. So I will name this as silver underscore customer underscore orders. Let's say silver underscore cust underscore orders. Okay. And then I will mention a comment because this is very important, guys. Commenting is the good practice, and I always recommend my team, my fellows, to have a meaningful comment in all your DDLs, even in all your columns. Okay, it's very, very good practice to have a proper commenting section. Okay, so let's say the comment I will say is cleaned and joined customers and orders dataset. Cool. Now I will mention alias and then I will say select something something. Then I will go down. I will fill that later from my bronze layer, bronze dot orders, and I will name this as O. And see, guys, it is automatically guessing what I am looking for. So I will just click on tab. Then I had successfully created my join between my orders and customer table based on my customer ID. Okay. And let's also pull all the columns. I will say O dot star, comma C dot star. And yeah, I guess this should work. Oh, I hadn't mentioned row. Actually, the tables are row underscore orders and row underscore customer. I guess here also it is wrong. Maybe I just put O dot customer ID. Yeah. Similarly, I need to put C dot customer ID. This looks good. I had fast forwarded and I had pulled all the required columns from my orders table and from my customers table. And now the first thing I will do is I will just click on this dry run option and I will see if this code is working as expected or not. Cool. And see, guys, it had successfully ran and I can see the data inside this newly created table. I can also see the performance, how much time it take, how many rows it had read, and how many final rows it had written. So yeah, so let's minimize this, or even you can click on this X and then let's run this one. So I will just click on this run pipeline and it will start running my materialized view. And once this ran, I will show you the materialized view inside my silver schema. So it had ran successfully. Now I will go to another tab. I will click on this silver schema and I can clearly see my table. I will click on this table, silver customer orders, and I can see my table here. So now I can even query this table, and in order to see my data, I can just go to my this option and I will go to workspace, and then I will go inside this and let's create a dummy notebook where I will just query from this one, and I will just name this as testing notebook. Okay. And here I will just select SQL as option, and I will just say select star from my SDP underscore. Let me click on catalog, and my catalog name is SDP underscore YouTube underscore demo dot silver dot wow. I will just run this one. Shift plus enter. And see, guys, it had successfully given me the joining result inside my materialized view. This is how we can create a materialized view using SQL. Now let's go back to your Spark Declarative Pipeline, and then I will shift myself to my silver customer orders. And now it's the time to write the PySpark code to create the same table with a different name, right? This is also important. So yeah, for that, first thing I just need to import my library. I will say import PySpark. I will say from PySpark import pipelines. Then I will say from PySpark.sql, PySpark.sql, import functions, let's say as F. Cool. And now I just need to define a decorator, which is dp.materialized view, materialize underscore view. And yeah, so this will ensure that my final output will be a materialized view. Cool. So inside this, I first need to mention the name of the materialized view. For that, I will just go to my this SQL file. I will copy paste the same name, and I will add underscore py in the table name so that you can actually see that it had created another materialized view. Okay. And then I will also add a comment. Comment is equal to, I will just copy paste the comment from there only. And I will say control V. Yes, that looks good. Now I will define my function. Okay. And in order to define the function, obviously I need to say define silver underscore cusp underscore orders underscore pi. And then I will read both the tables which are there in my bronze layer. I will say orders underscore df is equal to spark dot read dot table, and then I will mention my location from the bronze layer. I will go to my SQL file and I will copy paste this from there, control C and control V, and then same thing I will do with the customer df. I will literally copy paste this line, and yes, I will say cus df, and then here I will say raw underscore customers. Yes, that's done. So now I have two data frames which is holding my bronze layer data. So all I need to do is now I just need to return some output, and obviously I need to join these two tables. So I will say orders underscore df, and I will just name this as, let's say, O, and then I will say dot join. With whom I want to join? I want to join this with customer underscore df. And on what basis I want to join this? And on what basis I need to join this? I need to put that here as well. I want to join this on the basis of customer underscore ID. Now we had written the code for materialized view. I had mentioned couple of columns. I will click on this pipeline and I will run this pipeline. Hopefully this should not give me any error. Actually, I should be first doing dry run, but yes, hopefully everything looks good to me. Yeah. So it started running both. It had done the full refresh and it had loaded the 524 records. And these records are same as my SQL records. And this is the expected, right? Because we are doing inner join in both SQL as well as in Python, which is good, which is good. So now all I just need to do is I just need to copy this name and I just need to check if this is also having the same count or not. So I will just copy paste here. I will copy all the other things and I will just change here from Python to SQL. And then I will just say select star. Hopefully this should work as well. And here I am not pulling all the columns as you had seen. I am pulling limited number of columns. So obviously in output, I am expecting limited number of columns. So yeah, as expected. 524 rows, 524 rows. Same output in both SQL as well as in Python. This is how you can utilize anything, either SQL and Python, and you can create the materialized view. Make sense? Similarly, you can create the temporary views as well. All you need to do is instead of materialize, you just need to mention temporary. See, it is already recommending me. I will just say this one. And here also in the orders.sql, instead of materialize, you just need to mention temporary and you are sorted. Cool. So this is how you can create materialized views as well as temporary views as per your requirement. Now let's try to insert couple of more records because this was the first time and it had processed all the records. Next time it should only process the incremental records, right? So I will just go to my notebook and I will just create a new code and I will just insert couple of more records inside my SDP YouTube demo catalog and then my bronze customers table. And the customer table, I guess it's raw underscore customer. Yes. So let me try to run this. It might fail because I had just created it using AI. So now this is done for the customers table. Similarly, inserted 5 records for my row orders as well. Now, if I go back to my pipeline and if I run both the pipelines, I will just click on this run pipeline. This time, it should process the incremental records. It's running both. Let's open any one. As of now, it is having 524 records. So it should increase the records. See guys, this time it is saying that it had incrementally pushed the data. It hadn't pushed all the records. It had only pushed the incremental records. So if I go to my this one and if I open this one, I can see now earlier I was having 524 rows. Now I am having, as per this notebook, as per my pipeline, I should be having 533. So let's cross verify this. I will just say control plus enter. I will just close this one. And see guys, it had successfully updated 533 records for my SQL as well as for my Python. Let me run my Python as well. And yeah, it is fetching the results. And cool. See guys, 533 for Python as well. This is how it incrementally pushes the data from bronze to silver when the next batch of data coming. It is not doing truncate and reload. I will just click on this X. Now let's create another pipeline for the streaming purposes. So I will click on these 3 dots and I will create a new file, which will be my streaming file. So I will say stream underscore customer underscore orders dot SQL. Okay, I will click on enter and let's start working with my streaming using SQL. So first thing first, I will just copy paste my materialized view code as it is here. And then instead of materialized, I will say streaming. Working with SQL is very easy, right? So then obviously I will just say underscore stream. Okay. And with Python, I will say underscore stream underscore Python. Okay. In this way, we can differentiate. So obviously streams are not views. These are tables. So I just need to change from view to table. Cool. So yeah, now I need to mention stream keyword here, which will order this SQL that please treat my row underscore orders table as a streaming table. And as you know that streams are append only. Whenever I am doing the entry, it will keep on appending the data. Instead of calculating whether it's upsert like in materialized view, it will keep on appending your data. Cool. And I just want to mention the stream on my main table, which is my row underscore orders table. You can mention stream on both as well. It is fine. But as of now, I am just playing with one table. Now, I had created this table. I will just dry run this table. And hopefully this time it should not be giving me any errors because I had just copy pasted the already running code. Yes. So it is not giving me the error. So now I won't run this directly. I will show you the lineage. So in the lineage, you can see my materialized view, which we had created. And now you can see one more, which is known as streaming table. Makes sense? So this is how it is managing the things. So now obviously if I just click on this run pipeline, it will run all the things. Now I don't want to run everything. I just need to run my stream table. So I will just click on this run of stream table option. So it will start running my only stream table. Okay. And yeah, it is running. It is setting up my table. Yeah, it had successfully refreshed my streaming table. So let me go to my notebook and let me just create another code, and I will just copy paste the name. This is the name of the table. And yeah, I will paste it here. I will select here SQL cell, and then I will just say select star from this one. And this should be working as expected. Yes, let me run this now. Perfect. So it had successfully streamed 533 records. If I insert more records, it will just keep on appending the records. Okay, so this is how stream works. I'm not going to insert it. I'm just leaving it to you guys. Whole motive of this Spark Declarative Pipelines is to help you understand that how you can work with SQL as well as Python and what are the functionalities which you can use, right? So I am leaving this insert check to you, but I am going to create the same Python file as well to show you the Python working as well. Okay, so let me go to here and let me go to pipeline graph, and you can see that stream had ran successfully. Now I will just click on these three dots and I will create a new file. And this file is obviously Python file for the streaming. So I will just name this as stream cust order py dot py. Okay. Yes. Now again, I will just copy paste my existing code and I will change the things inside my existing code only. We'll just say Control C and I will paste my code here, Control V. First thing first, I just need to change from materialized view to streaming table decorator, streaming underscore table. So it is automatically creating a lineage for me, right? So this is the beauty. I will say silver, I will say silver, but I will just put stream in front. I will say stream underscore silver. That looks good. Then I will come down here and here I will again mention stream. Now I need to convert this into streaming tables, right? For that, I need to say read stream. Okay. And this will now start treating this orders data frame as a streaming data frame, and this raw table, it will treat as a streaming table. Cool. So yeah, I guess other things should be same. Yeah. Let me try to dry run this as well. It failed because I was mentioning streaming underscore table and there is no decorator naming streaming underscore table. I just need to mention DP dot table. And if I dry run this, hopefully this time it should pass. Yes, it had successfully dry ran all my 4 Paler files. So now it's the time that I just trigger this one and it started running. I will just go to this performance. It started running and it is running. Perfect. It had ran successfully. This is how you can work with streaming as well. Let's see that data in the streaming table as well. We'll just go and I will just paste here, change from Python to SQL and copy paste all the other details from here. Control V. Yes. Oh, it might fail. Just need to put modular SQL and let's run this. And see guys, it had successfully processed my streaming table as well. And as you know, in my SQL, I am mentioning all the columns, so I am seeing all the columns. But in Python, I had mentioned couple of columns, so I am only seeing couple of columns. So this is how we work with streaming tables as well. And please do remember that streaming tables are append only. If the new data is coming, it will just keep on appending. It won't be doing any kind of upserts. Okay. Now let's create one table in silver as well, because we are just keep on creating the things inside the bronze as well as silver. We hadn't created anything in the gold layer, right? So we can see that in silver we have two materialized view, two streaming views using Python SQL. Let's create something in gold as well, right? It should not be looking empty. So for that, I just want to create a, let's say, a table or materialized table in the code layer. I will just copy paste this code here. And here, a materialized view on top of my this streaming table, okay, in the gold layer. For that, again, I will say at the rate BP dot, and then I need to mention the materialized view and yes, and then I will open this bracket and I will copy paste my name and comment from here. I will just change silver to gold. Control V. I just need to maintain the indentation. Here I will say gold. Okay. Yes. So here instead of silver, this time I will change this to gold and I will click on save. Perfect. Now I just need to define the gold function as well. So I will try to copy paste wherever I can. Just copy this one and try to tweak this one only. I will say gold. And then I will say this as, let's say, gold df. And then here I need to say that dp.read. dp.read. What do I want to read is, I want to read this streaming Python. I will mention my Python here. Perfect. And obviously indentation issue. I just need to ensure that there is no indentation issue. Perfect. And then I will return. And what I will return is, I will return gold underscore df dot. I will group by my product category. I will mention product underscore category. And then I will group by gender as well. Let's say I want to see gender aggregations as well. Then I will say .agg, as you already know how we work with PySpark. And then I will mention app.count of order ID. And I will just name this as, let's say, total orders. Perfect. And then in aggregation, I had mentioned first thing. Then I will again mention second column. I will just add a comma. And then second is, let's say, f dot count distinct. Count distinct. Perfect. And then I just want to count distinct product names. And I will just name this as total products, let's say. Perfect. I guess this should work. And yeah, let me try to dry run this as well. Now let's run this pipeline as well. And I guess by clicking on this run pipeline, I had triggered all the pipelines. But yeah, that's fine. But now, if you see, it is showing me the lineage from my streaming silver table to my materialized view gold table. So this is the beauty. And this was the capability of Delta Live tables, which was automatically creating the lineage for us. And we don't need to worry about the operational overheads, right? So this is automatically detecting that in my second materialized view, I am referencing the silver table. So that's where it had automatically created a lineage between gold and silver. Now, if I go here and if I just refresh it, I should be able to see my gold table as well. So maybe it might take time. Let me try to query this instead of waiting for this one. I will just go here. I will click on this code option. I will click on this SQL and then I will mention my dot gold dot my table name. My table name is gold customer Python. Let me, oops, let me run this and see, guys. It had aggregated the data based on my product category and gender, which I had mentioned. So now this is how it is showing the results in my gold layer. Cool. And it had also created a very beautiful lineage. Let's now discuss about another important construct used in Spark Declarative Pipelines. Those are append flow. What is append flow? So let's say this is my table, and more accurately, let's say this is my streaming table. Cool. So now what happens in streaming table? In streaming table, you just keep on appending your data, right? So it just keep on appending the data, right? So you are keep on appending the data. This individual stream table is by default known as append flow. Okay. So as the name suggests, append means adding at the end, right? So this by default is known as append flow streaming table. Make sense? Now, Jaswinder, we know that by default streaming table is appending the data. You said it is append flow. Makes sense to us. Then why Spark explicitly introduced the append flow? What is the significance behind it? Good question. So let's say you are having a multiple streaming table. Let me copy paste this one also. So let's say these are the three streaming tables. So let's say this is orders table from one country and this is the orders table from different countries. So let's say this orders table is only specific for India and this is for USA and this is for Mexico. So in this way, we are having couple of streaming tables which have all the columns same, but it represents as a different countries table. Okay, this is again hypothetical scenario. We are having couple of tables or specifically couple of streaming tables because append flow only and only works with streaming table. It does not work with materialized view. It can never work with temporary views. Okay, so now what happens? You have a final table as well. Okay, let's say this is not my final table. So now you need to append this table as well into this table. You need to append this one here as well. And you need to append this one here as well. This is where append flow can help you in getting the work done. Jaswinder, one more question. If we have a similar kind of multiple streaming tables, can't I just perform a union or union all between all these tables and I can store the result of those union or union all select queries into my final target table? Yes, you can do that. Then why, Jaswinder, this Spark introduced the append flow? I don't see any significance. Help us understand why append flow is different. Cool. That question actually makes sense to me. So let's say you are doing union all between these three tables. Okay, let me do that. Let's say you are just considering all these three tables. Okay, and you are doing union or union all based on your requirement. Okay, let's say you are doing union all. Cool. Okay, you are doing union all. Everything is working fine. Okay. Now tell me one thing. Let's say tomorrow this stream fails due to XYZ reason. Let's say due to schema evolution, stream table 2 got a new column. Or let's say there are some errors in the pipeline with the stream table 2 which made the stream table go down. Will the union all still work? No, right? It will eventually fail the complete box, isn't it? This is where append flow comes into picture because it is not treating everything as a tightly coupled as you are doing here. You are completely coupling out the whole tables into a single query. You are doing tightly couplement, but append flow, let me remove this, but append flow is not doing any kind of tightly coupled. It is treating my table 1 as an isolated table. Similarly, it is treating my table 2 as a separate isolated table and table 3 as a separate isolated table. In this way, if table B fails, it won't impact my final streaming table. It will still append all the data from table A as well as from table C. And it will wait till the time table B is getting fixed. Cool. This is the difference between doing a journal union all and using the append flow instead of doing the union all. Second impact is it will reduce the speed of the processing. Why and how? Just in the think guys, if you are combining all the tables, you are actually doing some calculations, right? You are actually creating first the complete data set and then you are passing the data set to the final streaming table. So let's say stream A is having 3 GB of data, but due to XYZ reason, stream B got 100 GB of data. Will you wait for all the streams to be encapsulated first and then you will be appending it? No, right? You want that stream A, if is having 3 GB, just append it into my final stream. You want the stream B also the same thing. With stream C, you also want the same thing. But if you are doing union or union all, you are eventually slowing down the process by first combining the results of all the streams and then you are going for appending. This will make your Spark engine process a lot of things and it eventually results into the slower performance. These are the two reasons where append flow will come handy because it is very loosely coupled. It don't care if the table B is having 3 GB or 10 GB or it is failing or it is passing. The tables which are in healthy state, at least it will append those data because it is streaming concept. In streaming, data should be available in the final layer as soon as we can. So that's where append flow differentiating my traditional union or union alls. Cool. Let's now implement the append flow. I will go back to my Databricks and now I will create one new notebook. I will say create a new file and the file name I am going to put is append. Now I will name this from Python to SQL because first I want to show you SQL, as SQL is something which data analyst, data engineer, data scientist, everyone knows. So definitely why not SQL? So yeah, let's create the append flow in SQL. But before creating the append flow, let's also write the definition of append flow. Okay, in order to, it is also important that I should give you the definition. So what is append flow? Append flow is a construct. It is a construct used to incrementally ingest or transform data by adding new records from source to target. And by add, obviously, I mean append, right? And this is limited to streaming table. Limited to streaming table. You can't create append flows on the materialized or your temporary views. Okay, you can only create the append flow with the streaming tables. Cool. Now, as we are clear what is append flow. Let's understand how we can implement the append flow using SQL. So for that, first, obviously, I need to create my streaming table. So I will say create or refresh my streaming table, and my streaming table name, let's say gold unified table, anything. Okay. Then obviously I will mention the comment is something which is non-negotiable for me, guys. I always prefer, let's say, consolidated table for all the data from multiple tables, multiple streams, not tables. Ensure that you are pulling data from streams. If you are pulling data from materialized views or temporary views, this will gonna fail, and you definitely will see this, and I will show you as well. Okay, so let's first try to load the data from these two stream tables, stream cust orders.py and stream cust orders.sql, because these two are the streaming tables. In order to load the data from the streaming tables, first thing we need to attach the first stream using the flows. Okay, let me give some comments as well. So first thing is declare the main target table. Okay. And it should only be declared exactly once. That is also important, right? Then second thing is attach the first streaming source flow. Okay, flow is very important here. We need to attach the streaming as a flow. Cool. So in order to do that, we just say create a flow, and my flow name, let's say append from Silver SQL. Okay. And then I will mention insert, because obviously I need to insert these things. Insert into this one by this error. Okay. I hadn't mentioned the semicolon here. Now this error is gone. So by name, this is the template. And then you will mention your query. Let's say select order underscore ID from my stream, and the stream name is, let's copy paste. I will open this one first, my Python file. Are you noticing one more thing? That I am interchangeably using the Python table as well as the SQL table, because obviously this is self-explanatory, right? That's what we can use Python, PySpark, SQL everywhere in this Databricks. So this is the first streaming source. In order to create the second streaming source, I again need to create the flow. I will just copy paste this. I will just copy paste this one down here, and I will just change the table name. Okay, in this time, I need to use my SQL table name. My SQL table name, let's copy paste from here. Control C, and then I will put Control V. Control V. Yes, that's it, guys. That's how we define the append flow when we have multiple streaming tables as the downstream tables. Let's try to dry run this, and hopefully this should work. Let's see. See. Yes. So this is the time that I should run my this code. I won't click on this run pipeline. Obviously, I know that it will run all my 5 sequels. So as you can see, my beautiful lineage, I just need to run this gold unified table, because this table is built on top of 2 streaming tables. And let me make it little bit big so that you can clearly see. Are you able to see? No, I guess. Yeah, now you should be able to see. Materialized view, streaming table, skimming table. So here I have an option to run this specific file. I will just click on this one, and it will only run my append flow.sql file. Let's go to the performance. It is running. And yeah, it had successfully started, and it had considered both of the table to refresh into my final table. But if you had done UnionAll, it will be only spinning one query log. And if that is failed, it will not be having any kind of data processed in your final table, right? But in this case, if you can see, it had spinned 2 query logs. So in production, hypothetically, let's say you are having 100 query, 100 tables. So it will eventually spin 100 logs. So out of 100, even if 10 fails, 90 will at least will be processed successfully. This is the beauty of append flow that makes append flow different from union and union all. Cool. So now I told you that I will also show you that what will happen if I try to use the materialized view, right? Let me show you that as well. I will just copy paste this one below. And this time, instead of mentioning my streaming table, I will go to my materialized view file and I will copy paste my this materialized view table name. And now I will show you the error. This is also important so that you will never do the mistakes. Now let me dry run and let me show you the error. It failed. Why it failed? View problems. See guys. Oh, okay. This is my mistake. I cannot have a same name. So I just need to put here, let's say Matt. Now I should dry run this. No problem. We can literally rerun this. See guys. See guys. Spark runtime exception, Databricks exception, this exception, that exception. Why? Because you cannot process this materialized view. If you just remove this, or let's say if you just comment this out, everything will be in the perfect state. Let me dry run this again. See guys, everything is in the perfect state because append only never allows materialized views or temporary views to ingest the data. Okay, so you now are very clear that what is append flow. And now I am going to implement the append flow using Python. So now I will create one more file. I will name this as append flow underscore py, append flow underscore py dot py. Now let's create Python append flow. For that, I will go to my Python notebook and I will copy paste my first two scripts which are importing some libraries. Then obviously first thing I need to create the unified streaming table, right? And in order to create that, all I need to do is I just need to mention dp dot create underscore streaming underscore table. That's it. That's it. Nothing more than that. Okay. dp dot create underscore streaming underscore table. Then I need to mention the table name. Let's say name of the table is gold table Python. Cool. Perfect. Then the second step, yes, append the flow for flow A. That's it. So in order to do that, I just need to mention dp. I just need to mention a new decorator, which is at the rate dp dot append flow. That's it. It is really very easy to work with PySpark, right? I never face any hurdle. And if I do, no problem. We got our Jenny. Our Jenny bro is here to help us. So then I will mention my target table name. I will define my append flow. And obviously after name, I also need to mention the name. This is also very important, which will differentiate. I will say flow underscore A, and that's fine. And then no, sometimes it two mistakes, no problem. We can rectify this. I just need to mention my table name here. And yes, now I will just copy paste this for flow B as well. I will say this is for flow B, and here also it should be flow B. Yes, this looks okay. And now I just need to mention my table name, right? Everything looks okay to me. Just the table name I need to mention. And obviously for that, I will just I will go to my streaming one and I will copy paste my streaming table name, because as we are already know that we can only create append flow using the streaming tables. So first streaming table is done. Let's continue with the second Python streaming table. I will open this one and I will just copy paste this one as well. Yeah. Here. Perfect. Yes. And I guess this should work. Let me dry run this and let's see if this is even working or not. I guess this will work because I was recently working with the append flow in my project. So there it was working. Oh, yeah. Sorry. I have to sometimes ignore the auto complete option because it had just created a disaster for me. Yes. Now I guess this should work. Let me try run this again. Yes. This worked. That's what I was thinking because I literally was using the append flow in my project and it was working fine. So yeah, that looks good to me. Now let's go one step back and go to this gold table Python, this one, and let me try to run this only end flow gold table Python. This one. Oops, I'm so fast. Yeah, this one. Let me click on this run option. It started running. Let me go to the performance tab. Yeah, it will run because if dry run is passed, there is very less probability that it might fail. So now again, it had created two locks, which is good, which is definitely good. It had ran also. Let's try to query this table quickly. I will just copy this and I will go to another tab. And here I will just mention select star from this one. Let's try to see the output. Oh, why? No. Okay, this is fine. This is fine. Okay. Oh, okay. I just need to mention my other things, which is this one, and copy paste, Control C, Control V. Hopefully this should work. Yes. Yeah, this is working. This is definitely working. And perfect. I got my outputs. This is how we can work using append flow. Got it? We had seen both SQL as well as Python. And if you ask me personally, I always prefer Python. Okay. Because you are working with Databricks and majority of the Databricks developers love Python. Okay. And we have to love Python, right? Because this is bread and butter for us, right? So yeah. But again, if you are from Snowflake background, if you are a data analyst, don't worry at all. Don't worry at all. Till the time you are already aware about Spark SQL, you know how we can implement the SQL within the data frames, everything you know. And now I am also telling you that how you can use SQL use within the Spark Declarative Pipelines. Where you will get this level of knowledge, guys? Nowhere, right? So that's all about append flow, guys. Cool. Now it's the very time that I will talk about CDCs in Databricks Declarative Pipelines. And this is an official documentation, and here they had mentioned a lot about how we can implement the CDC view within the declarative pipelines. And you can obviously read through that. And there is a lot of knowledge here. And here also you can get a lot of knowledge. And I had read that and I personally love this documentation. And so do you should love it. It's very, very helpful. Cool. So now it's the time to implement CDCs, right? So now we will be implementing both SCD Type 1 and Type 2. Okay. You will say, Jaswinder, we already implemented SCD Type 1 and Type 2 in our Databricks using PySpark or using SQL. But now there is a revolution which came in the declarative pipelines. Had you noticed the code which you had written for type 1, type 2? Can you give me a number that at least how many lines of code you need to write? At least maybe 100, maybe 150, right? But now what if I say that you can implement the type 1 and type 2 with just 7 or 8 lines of code, let's say. Wow. Yes, guys. This is now possible. You can implement SCD Type 1 and SCD Type 2 like that within a minute, within a 2 minutes. So let's say you can literally do that very, very, very fast. There is a complete template provided by Databricks. and it is only of 7 to 8 lines. That's it. Isn't it this a revolutionary? This is revolutionary. And when I first seen this, I was totally shocked because I used to write a lot of code to implement the especially type 2. And it sometimes even took me half day to implement the complete SCD type 2 for couple of tables. But now with this functionality, which I'm going to discuss with you, you can literally create the type 1 and type 2 within minutes, and doesn't matter it's a one table or 10 table or 100 tables. You can literally give one table at max 1.5 or 2 minutes and you are done and dusted. Wow. But before that, I am just guessing that you should know what is SCD type 1, what is CDC, and how slowly changing dimensions work. If you don't know, I don't know what you are doing then. Just go to Google, okay, and search modern data warehousing by Data to Dollars. And even you can go to my channel and you will find this very beautiful 3 hours modern data engineering tutorial covering all the required topics till date, which is there in the data warehousing. I had covered everything: data vault, data lake house, referential integrity, Apache Iceberg, Delta Lake, CDCs, implementing CDCs, and whatnot. You can literally watch this 3 hours tutorial and you will be someone who is ready to face the data architects in your team. If they say anything, you will be knowing the answers in advance. Okay, so please do consider watching this one, and this will be very helpful after watching this one. If you are going to your architect and if architect is saying something, you will be very clear that what exactly he is saying. You will never be required to Google the things that I don't know what my architect is saying. I just need to circle back with some other person. Hey, what this said? Hey, what is this? You don't need to do that. Cool. Do watch this one. But if you already watched this, or you already know what are SCD type 1, type 2, how to implement them, you are sorted. Let's now jump directly into creating CDC file. And as always, I am going to start first with SQL. I will again click on this one, these three dots. I will click on create file and I will name this file as cdc.sql. Perfect, perfect, perfect. Now, do you remember append flow? Append flow is the younger brother of this CDC. What do you mean by younger brother, Jaswinder? Okay, you know append flow only works with streaming tables, right? CDC also works strictly with the streaming tables. This is why they are brothers. Okay, so yeah, now let's come back to the topic. First, obviously, I will also add the comment. Let's declare the streaming tables. Cool. So you already know how to declare it. Create or refresh my table and then the table name. And let's say table name is, because I am going to create this on my silver layer. So I am going to give this name as silver underscore customer underscore SCD1. Okay. Okay. Now again, I need to mention the comment. I will say implementing SCD type 1. Then I will just copy paste below. I will put a colon. Then I will mention here SCD type 2, implementing SCD type 2. So now I had declared my streaming tables for both SCD type 1 and type 2. So obviously after declaring it, we need to apply CDC code SCD, let's say type 1 first. Okay. So what is type 1? It's absurd, right? Let's mention that. How we do that? No, don't go with this auto recommendation. I sometimes I love it, sometimes I hate it. And this is the time when I hate it. Okay. So now in order to apply the CDCs, there is a specific template which is provided by Databricks Declarative Framework. Okay. And this template is different for SQL and different for Python. Okay. So you need to learn this template, or you can even search it on Google and you will get it. What is a template? Template is apply. Then you will say changes. Then you will say into. Which table you want to apply the changes? I want to apply the changes on this SCD type 1. Cool. So what is why this is giving error? Because I hadn't put semicolon. No problem. Now, after that, from where I need to apply? From the stream, and the stream name is what? What, Jaswinder? You hadn't created any stream? No, I hadn't created any stream. Okay, no problem. But I have my scripts ready. I will go to my testing notebook, and here I am going to create a table inside my bronze layer. Okay, and then I am going to insert two entries. First entry, my name, my age, my city, and second, a dummy entry. Okay, let me insert these two entries. Let me run this quickly. And yes, I had successfully inserted two records into my CDC raw customers table. Right now, I can use this table. Okay, I will say stream of. I will just copy paste it. Why to waste your time? Stream of this table. Okay. Now I need to mention the keys. Keys means the primary key. I will say keys, and I need to mention all the keys. In this case, my primary key is customer ID. Okay. I will copy and I will paste it here. Customer ID. Okay. Then I need to mention a column which is known as audit column. So what is the audit column in this case? In this case, my audit column is last updated date. And this column will help me in understanding the version of the record, right? So obviously I need this one as well. Without that, I cannot implement SCD. So I need to say sequence by, then I will mention my audit column name. And then last one is stored as SCD type 1. And this is the template of implementing SCD type 1. Make sense? Perfect. Perfect. Same thing, I will literally copy paste this complete one below, and I will just change type 1 to type 2. Instead of absurd, I will say historical. And here also I will say 2. And here I will also say 2. Oops. 2. And that it, guys. That's all. Wow, Jaswinder. Within minutes, we had implemented type 1 and type 2. Wow. Crazy, crazy, crazy things. Right? Let's try to dry run this. Dry run is running. And if you get stuck in anywhere, don't worry at all. Just call our bro Ginny. Ginny is very, very mature now. It easily answers all the question without creating much hallucinations. Okay. Anyway, our code ran. So now I will go to my pipeline graph. Okay. And now I need to run SCD type 1 and SCD type 2. I will just first increase it. And these are my SCD type 1 and type 2. Let me run this. SCD type 1 is running. Yes, it is running. And perfect. Type 1 ran successfully. Now let me run type 2 as well. So this is my type 2, and I will go to, oops. This is my type 2, and I will just click on this run option, and it will start running my type 2 as well. Perfect. Perfect. So it had ran my type 2 almost. Yes. Now I can see my data because this is the initial data. Obviously, the end date will be null, right? And same way, if I just go to my testing script and I try to query my type 2, let me query it. I will say select star from type 1. Let me run this. Perfect. This is my type 1 data. And similarly, I will just query my type 2 data where I will be having end at null. Perfect. This is my initial data, so it does make sense to me. Now I will insert two new records. Earlier, my location was Amritsar. Now my location is Pune. And similarly, I am going to insert a new record. So in type 2, what should happen that my Amritsar one should have an end date, but my Pune should be having an end date as null, right? So let's insert them first. This is the existing record getting changed, and this is the new record. And I had inserted both of the records. Let's try to run both SCD type 1 and type 2 again. Go to this one, and I will click on this one again, and it started running, and let it run. So in type 1, it will change in place. Instead of Amritsar, I will immediately see Pune, right? Let's wait for this run to complete. I will stay on this data screen only to show you. See guys, the new record 103 came, but my existing record, which was having location Amritsar, now it's Pune. This means SCD type 1 is working fine. Very good. Very good. Now let's see SCD type 2. I will run this one quickly. And yeah, let me show you. As of now, my Amritsar is null. But after this run is completing, my Pune should be null and Amritsar should be having a date. Right? Let's see that. Run, 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 run. Yes. Yes. See guys, now my Amritsar is having the date, which is expiry date. And now my location is Pune, so it is saying Pune and end date is null. Cool. That's how quickly we can implement SCD type 1 and SCD type 2. And I had just shown you with SQL. Now I will show you with PySpark as well. Let's create another file. I will click on create file and I will name this as Python CDC python.py. Cool. And obviously guys, I just need to rerun my insert create table scripts. I will just rerun this so that my table will only be having two records. Okay, because I need to just go into the initial phase. I am back into my initial phase. That's good. That's good. Now, first thing, as I always love to copy paste, I will copy paste. I will copy paste these things. And yes, yes. Now I need to create the streaming tables, and you already know, isn't it? Create streaming table. That's it. And then mention the table name. Name is equal to, let's say, silver customer let's say SCD1 and then Py, because we are using Python. Similarly, I will copy this one and I will paste below as it is. Just I will change SCD1 to SCD2. Perfect. So I had created the target streaming tables. Creating target streaming tables for CDC. Make sense? Perfect. Perfect. Now, obviously, let's implement SCD type 1. SCD type 1. Okay. So what is the syntax for that, Jaswinder? We have the inbuilt provided function by Databricks, which is known as create auto CDC flow. Wow. I will say dp dot create underscore auto underscore CDC underscore flow. That's it. That's it. Now I will mention couple of parameters like what is my target table name? What is my target table name? Obviously this one. Copy paste, copy paste, copy paste, Jaswinder. Quickly. You just told us that we can implement within a 1 minute. Show us in a minute. Cool. Now I will mention my source. What is my source? My source is my this table. Copy paste, Sundar, immediately do that. We don't have much time. Cool, cool, guys, cool. Now, obviously, next is keys. Mention your keys. What are your keys? Obviously, it's customer ID. Customer ID. Done. Done. Now, fourth, sequence by. It's same, right? You can see it's very similar to my CDC.SQL. All the things are same. Last updated. Perfect. This is also done. And the last thing is, what is the last thing? Store as, right? So I will say stored. Oh my God, it is automatically recommending me. That's it, guys. Now I will copy paste it. And here my 1.5 or 2 minutes are completed. So, okay. Yeah, you can still say you failed, Jaswinder, but it's fine. I'm okay. Because even though I had implemented in more than 2 minutes, I am still okay. I am 100% fine. Now let's do dry run. And if anything fails, no problem. We have our brother Ginny here. He is the lifesaver. Cool. Coming back to the topic, be professional, Jaswinder. Yeah. So it ran successfully. Okay. Let's go to performance. Not here. Let's go to my pipeline graph and let's run this Python CDCs. This, no, this is not these two. These are my Python CDCs. Let me run my SCD type one first and I will stay on the data. So I will see only two records and so do with my SCD type 2. But in SCD type 2, I should be having end date as null. Obviously, let's wait for a minute. I can see the records in type 1. Let's run type 2. Go here and just run this one. Go to my, okay, I will stay in data. I won't go to performance. Okay, it's running. Yes. Happy pass scenario. Perfect. Now let's insert the data. And before that, let me again show you here also. Oh, my table name is different. I'm so sorry. I just need to grab my table name. I will just click on this X button. And this is my table name now, Jaswinder. What you are doing, just let me mention my actual table name so that you can see that everything is in the initial state. Perfect, Jaswinder. Now let me run this insert scripts again. Okay, it ran successfully. Now let me rerun the pipeline. I will expand this. I will go to pipeline graph and I will again run my type 1 first. So now again, my city is Amritsar. And once this will complete, my city will go from Amritsar to Pune. And there is another one new record and that will also come here. Let's see. The Swindar city is Pune now. Now it's the time to implement, not implement, to run type 2 as well. Let's run this. No problem. It's updating my data. And see, guys, Jaswinder was in Amritsar. So it had ended my Amritsar time. Now I am back to Pune. Anyway, this is how we can work with SCDs using Python and SCDs using SQL. And mention in the comment section which one you like the most. I personally loved this one, but obviously I can't just be biased with PySpark because I am also a Snowflake person. Okay, I also love Snowflake as well. I can use both and I am not biased toward PySpark. This is how we implement SCDs. Let's now discuss about the sinks. Sinks are like the reverse ETL, which can help you to process the data back into any kind of external systems, let's say Apache Kafka or any kind of external Delta instances. And these are very low latency operations. Okay, so the whole purpose of sinks is to write the data back to any kind of external destinations. Okay, so let's go with the definition now. In Databricks Declarative Pipelines, sinks are output destinations that let you write processed transform data to the target outside of my Databricks environment. So this is very helpful when you have to write data outside of your Databricks environment. Then you will use sinks. Either in your event hub you want to write data, either in your Kafka you want to write some data, either you have some kind of custom Python sinks, or either you want to write your data in some external data table. So everything is possible using sinks. So if we talk about the supported sink types, obviously Delta Lake, where you can write your data within the Unity catalog as well as outside of the Unity catalog. And then it also supports Apache Kafka and Azure Event Hub, where you can stream data outside of your Databricks environment to any Kafka or any kind of events. Then we can obviously have a custom Python sinks as well, where you can store the data within your Spark Python data sources. Then there is a for each batch sync. This is the very custom level sync type where you can customize the batch by batch operations. If we talk about sync APIs, syncs are again the sibling of append flow. This means sync will only work with the streaming table and it won't work with any materialized views or temporary views, right? So in order to do hands-on on sync, Databricks Declarative Pipelines provide us two functions. First is create sync function, which is the most widely used function. And second is for each batch sync. This is a decorator which you can use for the custom logic. So it comes with a lot of flexibility to write all the custom logics. Let's now go back to the Databricks Declarative Pipelines and create the pipeline for the sinks. I am back on my Databricks environment. As things are something which require Databricks paid edition, then only you can write the data outside of the Databricks, but I am only having the serverless. So this means I can only write the data to the managed Unity catalog. Okay. So I will show you that only. For that, I just need to create a new file. I will click on this create file and I will name this file as, let's say, sync.py. And by the way, syncs are only supported in Python. You cannot write syncs using SQL. Okay, so this is the limitation. I had copy pasted my libraries. Now I will create a sync. In order to create a sync, we say tp.create underscore sync. You just seen it in my PPT, right? Then I will mention my sync name. First is name, and this is my target table name. You can say, I will say local, let's say silver, and then let's say order sync. And then I will mention my format, the target format. And I will say I want my target in Delta format. And then I will mention the options. What do I mean by option? By option, I mean the table name by which this sync should be getting created. So here I will mention my key, which is table name, and then I will mention the value, and my value will be the table name which I am expecting as the output. This is the name of the sync, and this is the table name which this sync will create for me as the output. So I will say SDP YouTube demo dot silver dot, let's say, sync underscore orders. So yes, this is how I had now defined the sync. So as the sync is the sibling of append flow, I need to mention append flow as well. So this is the template which we usually follow. Whenever we are defining the sync, we need to define the respective append flow as well. So what should be the target name? Target will be my same. I will copy paste. This name will become my target for my append flow. Say target is equal to this name. Perfect. And then I will mention the name of this append flow. You can mention name first as well. That's fine. So let's say I will give this name as flow to Delta sync. Okay. Let's say that. Yes. So this is how I had configured my append flow as well. And now I will create a function, let's say stream to local Delta, because I am obviously storing the information in local. And then I will mention my stream name. Let's say I will create customer stream and I will say spark dot read stream dot table, right? This is how we call. And then I will mention my table name, and for that I will go to my testing and I will copy paste this one. This is the table name which I created, row table. Let's use this one only. Yes. And then obviously I need to return. So I will say return, then I will say cust stream dot, let's say I'm looking for applying some filter, that my filter is that my customer ID should not be null. Let's say I will say f dot column and my column name is customer ID, and then what I want is not null. Cool, perfect. And then I also want to select some column. I will say select and I will mention a couple of columns. Let's say F dot column and I want column as, let's say, yeah, these only. Do I have these columns? Let me check quickly. I have customer ID, customer name, city, age. Customer ID is there. I just change this to customer name, customer name, customer name, and then I will say city. I will name this as city and then age. Age. Perfect. This looks good to me. Let me delete this one. Yes. Now I am going to dry run this first. I will click on the dry run and hopefully this should work. Yes. It had successfully ran. So now let me run this sync. I will click on this run pipeline. I will go to my pipeline graph. I will expand this a little bit and I will open my sync. And see guys, this sync had successfully worked and my whole pipeline ran successfully as expected. Now I will just go to my testing and I will try to see this sync. So how I can see this sync? I had written the sync inside this table, right? So I will just copy paste this table name, Control C. I will go to the tab and then here I will create new code. I will select SQL and here I will mention my select query, select star from this sync. Let's run this. See guys, it had successfully ran. This is not the ideal scenario where we are writing the sync within the Unity catalog itself, which is obviously self-managed by Databricks. This is just for tutorial purposes. Usually we use sync to write the data to the output destinations like Kafka or Event Hub or external data storage like S3 or anything like that. Okay, but as we are using the serverless and Databricks free community edition, so that's the limitation. I cannot go outside of my Databricks environment. So that's where I created the sync using the managed Databricks Unity catalog. Okay, but do keep in mind that this is not the general scenario for using the sync. This is just for letting you know that how you can create the syncs. Cool. Let's now discuss about another important topic which is very helpful for the data quality checks, and that is known as expectations. Okay. I will first create a file saying expectations.sql. What are expectations, Jaswinder? Expectations are just the data quality constraints which you can apply on your data sets. Okay, and this will act as a row level validation checks, and you can mention expectation as if you want to retain the row if it is violating the expectation, or you want to drop the row if it is violating the expectation, or you want to fail the complete flow. Okay, so it is very flexible. So let me write the definition first here. Expectations are how you implement the data quality constraints. Make sense? Within your data pipelines. This is known as expectations, mentioning the data quality constraints. So there are three type of expectations. First is if you want to retain by just giving some warning. Okay. And second type is if you want to drop the record which is not meeting the expectation, and third you can fail the complete pipeline if the expectations are not met. Make sense? This is all about expectations. Okay, so now let's obviously go and do the hands-on, and expectation are supported both with SQL as well as in Python. So definitely I will love to first create in SQL. So first, in order to create, I will create a streaming table. I will say create or refresh my streaming table, and I will give the table name, let's say silver orders, and let's say validated. And then here I will mention the constraints. It's very similar to mentioning the constraint in your DDLs. And then first constraint I want if my order ID is valid order ID or not. I will say valid order ID. This is my constraint name. And then I will mention a keyword which is expect. If I just mention expect, then if I mention the order ID, which is the column from my orders table, is not null. Okay, if I just mention this one, this is nothing, just the retain. It will just give me a warning in my output that order ID is null, but it won't drop or throw any error. Okay, so this is the retain behavior. Cool. Now I will just copy paste this one. I had validated my order ID. Let's also see if the sales is positive or not. So I will say positive sales. Cool. And here I just need to mention my column, which will go as a said sales amount. I don't know this column exists or not, but if this does not exist, I will create the column. Okay. So if the sales amount is greater than 0, till this time, this is again the retain behavior, right? Now, I don't want the retain behavior. I want the second type of behavior. In order to implement that, all I need to do is I just need to mention on violation. Then I will say drop the row. This is my second behavior. So what is this behavior? Drop behavior. Make sense? Perfect. Now I will again copy paste this one and I will define my final behavior, which is fail behavior. So all I need to do is after violation, I just need to delete the drop row and I just need to add fail, and I want fail to be updated in my logs. So I will say fail update, and that it, guys, that's it. Now after mentioning the constraints, obviously I just need to mention the table. So I will just say as, and then I will start doing my select thing. I will say select and I will pull my order ID column, order ID, and I will just name this as order underscore ID because I am using here order underscore ID. So I should be doing the same. Why don't I also do here order ID? Because I don't want the same things. Let's do here as well. Order ID greater than 0. That's the positive scale. Cool. So now order ID is there. What's next? Next is I need to get the sales, right? So do I have sales column? First, let me check. Let me do select star on this table and to see if I am having the sales column or not. Select star from, I will just move from Python to SQL and let's see if I am having any sales column here. If I don't having, I will just change it to some other column. No problem at all. But I guess I have. But let's check it. Uh, 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 Sales. I have sales column. Perfect. Perfect. So this should work. So I will say I just want to, what is the data type? Data type is 1, 2. No problem. I will just say, let's cast it. That's a good practice, right? Because sometimes in future you might get other things. So I will say cast my sales as double. Cool. And then I will mention this as my sales amount. Perfect. Perfect. And I need to mention my table. And obviously this is also something which only work with stream. And then I will mention my table and I will say stream of this table. P and paste it here. And yes, this should work. Yeah, I just need to mention a comment that this is my fail behavior. Okay, perfect. Yes, I guess this is fine. This looks good to me. Let me dry run this. Oh, I am defining both as the positive sales. Oh no, I can't have two constraint with the same name. Obviously, it's a typo mistake. So let's fix this. No problem. I will say critical. Let's say ID check. So now this should work. Let me do try run again. And yes, this worked. As of now, I don't think I am having order ID as null and sales amount less than 0. I don't think so. So if I run this, it will run as expected, right? But I won't run this now. I will run both my expectation.sql and expectation.python.sql together. I had dry ran it. This means there is a high probability that there won't be any issues. So I will create a second py and I will name this as pyexpectations.py. Cool. So now obviously I will just open any random Python file and copy paste both my libraries. Well, now remove this and then I will paste these here. And now here in SQL, I am having the expect keyword, and same in PySpark, I am having expect. How to call it, Jaswinder? I just need to say @dp dot expect underscore all. And this is the default one. Which is the default one here? Default one was retain behavior. So this is my retain behavior. Cool. So now I will mention my names and my conditions, right? Because here also I had mentioned two things, the constraint name and my condition, right? So why don't I just copy paste this one only? So this is my name. This is the name. And then what I want in as the expectation, I want expectation as order ID is not null. Again, I will copy and paste this here. Cool. This looks good to me. Now let's take one more step and let's define the reasonable sales as well. Okay. Reasonable sales, and I will put the value as sales underscore amount should be less than, let's say, 10,000. Cool. This looks good. But why this error is coming? Oh, I hadn't defined the table, right? So I need to define the table as well, right? Here also I had defined the table. So same thing, I need to define the table here in Python as well, right? But just in the you are doing, no problem. I will define the table. I will say df table, and then I will define the name of the table. And let's say the name of the table will go like silver orders validated underscore Python, and the comment which is important. Comment will go Python validation. Let's say now this looks good. And yes, again error. Oh, one more thing. This should be coming as a dictionary. Now this looks good. Now definitely this looks good. Expectation I am passing as dictionary in my PySpark. Second is I will say expect all or drop. So I need to mention @dp dot expect all or drop. Thanks for recommending Databricks. And then I will mention another dictionary. And let's say I'm looking for positive sales, positive underscore sales. And the value I am looking here is if my sales amount is greater than 0. Perfect. Yes. And then I will mention the third expectation @dp dot. Third expectation is of failure, right? So it will go expect or fail. Yeah. Expect or fail. Perfect. So now I will mention here again creating a dictionary. And then I will mention here, let's say critical ID check only, which I was doing. I will say critical ID check. And then I will mention my order ID is greater than 0. Perfect. Perfect. And this looks good to me. Now I will define my function. So I will say define silver orders validation py. Yeah, let's say this only. And then I will say return. I will remove this. And I will read this table. I will say spark dot read stream dot table, and I will copy my table name from my testing notebook. I will say Control C and I will paste it here. Perfect. And then I need to select couple of columns, right? So I will say dot select, and let's say I'm selecting f dot call, and the first column I will be selecting, let's say, is order ID. Order ID. Perfect. And then I will mentioning the alias, and let's say I'm naming this as order underscore ID. Perfect. Similarly, I will pull my product name as well. And the final column I want to pull is, let's say, sales. F dot column sales. And then I will say dot alias sales amount. Yeah, and this looks good to me. Let me dry run this as well. And hopefully this should not be failing. Oh, it failed. That is also important. Failures are important part. Here, I guess I don't need to put colon. Instead of colon, I guess I need to put comma. And then also, this is not the dictionary. So I just need to remove this curly braces, and I guess this should work. Let me run this now. Hopefully this time I should not be getting the error. Yeah. This is working. Now I will run this. Initially, it won't fail both of my expectations. Reason? Because I'm not having any sales amount which is negative. I'm not having any order ID which is null or less than zero. And I'm not having any order ID which is null. And I am even not having any kind of other dependency. So hopefully these two should pass. So what I will do is I will just click on this run pipeline, and I will go to my pipeline graph lineage, and I will open my expectations. The name of the expectations are Silver's order validated pi. I guess this one and then this one. Yes, Silver orders validated pi and Silver order validated. These two are my expectations. Let me rename this something else. We'll name this as EXP, and then this one also I will name this as EXP, because I'm not able to differentiate. Now I will rerun this. Now I can clearly differentiate that EXP means expectations. So both of my expectations had ran successfully because there are no constraint violations. Now let's create the constraint violation. So first violation I am going to create is order ID having null value. Okay, I will go to my testing, and I have this insert script from yesterday. So what I am going to do is I will just mention couple of nulls here. I will just enter and I will comment this one because I might need them. No problem. So yeah, let me run this one and let me insert some entries. In this case, I had inserted 3 entries. Cool. So now I need to again run this. One expectation is unmet. So maybe I should comment this in order to show you no problem at all. And here also, if I had mentioned this one, I will comment that this one, expect or fail. Let me comment this. So now it should not be failing, or maybe let's go step by step. What I will do is I will comment this one also. I will only run my first retain behavior expectation. And here also I will comment my expect all or drop. Yes. Now let me try to rerun this. And this time I should not be getting the error, I should be getting the warnings. See guys, this time my expectations had not failed. This time it is giving me warnings that I am having 3 values as null. See, it is showing me the fail percentage. It is showing me the expectations that 3 records are not having the valid order ID. So this is how you can work with expectation having the default behavior where it is retaining the record but throwing the warning. Okay, now let me comment this one and uncomment my second one. Do I have anything where sales amount is zero? I don't think I have. But let's do that. No problem at all. I will just comment this one and I will uncomment this one. And let's try to run this now. I guess sales amount is null also. So maybe that is also a violation. Let's see that. No problem. We can literally see that. Let me go to my performance tab. Okay, it's running. That's fine. This had ran successfully. This means if the sales amount is having any nulls, it had dropped those columns. As of now, I'm not seeing any drop because there are no sales amount which is less than 0 because they are null, they are not less than 0. But let's do that. Let's add a sales amount as negative. That is also something which is important. So I will say other column as sales. I guess sales. Perfect, sales. So inside the sales, the value will be minus 200.7045. And let me enter and let me comment them as well. Yes, let me do this entry now. Now my sales amount is negative. So it should drop one record. Let me run this. Now it is saying one expectation is unmet. Why? Because I had inserted a record with negative value and it is violating my expectation, right? So let me open this and you can see that there is one record which is violating the positive sales. This is how we can work with expectations, guys. It's really cool thing, right? So this is from SQL. You can also see the same in my Python as well. I will show you the Python as well. We should not be skipping the Python part because I know you are Python people. See, here also one is unmet. Cool. Dot underscore Python file. And earlier I was showing you expectation silver orders validated file. So here also same thing happened. One is unmet. Cool. Perfect. The third one and the final one. It's nothing like you need to implement this one by one and comment it out. You can implement all together because I had put the wrong conditions. That's why I need to do this way. Yeah. Now let me comment this one and let me uncomment this one. Now again, I need to insert the order ID with negative value. No problem. We can happily do that. I will say minus of 20. Order ID is minus of 20. Cool. Let me run this again. I had inserted one record. Yes. And now let me run this. And this time, both of my expectations should fail. Right. Let me see the performance directly. And here only I can see and log the failures. See guys, both of them failed. If I open my SQL one, the failure is saying one unmet and thus it is throwing the action as failure. And if I open my Python one, let me go back and open my Python's same error I will be getting here. One unmet and it is failing because critical ID check code failed. And number of records which was detected is 1 because I had only inserted one negative order ID. This is all about expectation and this is how we work with expectations. Cool. Now as we are done with expectations and syncs and everything, the last part of the Spark declarative pipelines is to schedule the pipelines, right? And the best part is that you can schedule the Spark declarative pipelines with your SQL as well as your Python notebooks. So let me show you how we can schedule the Spark declarative pipelines with our traditional notebooks. Okay. So now you know that these are my all the files, including Python as well as SQL files. So if I just go here and if I show you pipeline graph, and this is how this complete lineage looks like. And now what I'm going to do is I am going to click on the jobs and pipelines and I can see my ETL pipeline here. This is not the job. This is ETL pipeline. Okay. So I just need to click on this create option and I need to click on jobs. And you can see they had given the details that what is job? Job is to orchestrate notebooks, pipelines, queries, and more. And what is ETL pipeline? ETL pipeline is to build ETL pipelines using SQL as well as Python. And then we have ingestion pipelines. This is for ingesting data from popular applications and databases and any kind of popular file sources. Cool. As part of Spark declarative pipelines, we had built the ETL pipelines. But in order to schedule the pipeline, I need to click on the job. I will click here and then a very beautiful interface will open in front of me. And first thing first, I will name this as ETL schedule, let's say. Cool. Yes. And now I get an option called add another task. So I will click on this option. And what I need to add first, I want to add ETL pipeline first. So I will click here and I will name this pipeline as SDP pipeline, or let's say SDP demo YouTube. Cool. So this is a pipeline. I will say save and continue. And then I need to mention the pipeline. And this is my pipeline. I will just select my pipeline. Perfect. And then do I need to make any retries? I don't want any retries. I just want to run this only once. And any duration threshold if I want. No, I don't want anything. I am okay. Any notifications if I want, maybe I can add some notification. I can select email address and then I can mention my email on which I want to receive the notifications. Okay. And then I can have the success notification, failure notification, any other start notification as well. Then I can click on save. Okay. If you want, that's obviously that's project to project, but you should know that. Cool. So I don't need any duration threshold, so that's fine. So all I will do is I will just click on this save task. And I had successfully created my first ETL task. Now, after this task, I want to schedule my this testing notebook as well so that it can automatically run and it can show me the results. Okay. Then I will again click on this add task and this time I want to schedule my notebook. I will click on notebook and I will name this as, let's say, testing, and then I need to select my path. I will go to users, then I will go to my email, and then here I will go to SDP pipelines and SDP pipelines and testing. Cool. Then I will click on confirm. Perfect. So I had selected my notebook and it is depending on my SDP demo YouTube. That's fine. That's what I want. And do I have any parameters? No, it don't require any parameters at all. Then I will click on this create task. And I had successfully created my pipeline. Now I need to schedule this pipeline. So here in the side option, if I close again and if I open again this button, I have a option called schedules and triggers. Okay. So I will click here on add trigger and how I want to schedule. Do I want to have a scheduled? Do I want to trigger this when the file is arriving, any table update or any other operation? I want to schedule this. So I will click on schedule. Then it is asking me the interval or it is asking me the schedule, anything I can select. Then I need to select the frequency. Is it every day or every minute? Let's say I want every 1 minute. Okay. And then I will click on this save. And this had successfully updated my schedule as well. Now I will go to this runs and I will wait for a minute to see if this had scheduled and it had ran as expected or not. And see guys, it had started running and you can see that it is launched by the scheduler. It is not launched manually. Okay, I will show you manually as well, but you can clearly see that it is now running state. And if I just click on this one, I will be seeing the running job as well. This is how we can work with scheduling the ETL pipelines as well as the notebooks within the Databricks interface. Make sense? That's all about Spark Declarative Pipelines, guys. And see, guys, once the schedule one is running, because I had scheduled for every 1 minute, it immediately queued my next schedule. And once the first pipe will complete the run, it will immediately trigger my second schedule. Okay, see, the third schedule is also triggered. This is how scheduling works. Let me stop the scheduling. I will just go and I will say edit trigger and I will click on trigger status post and then I will say save. Okay, so in this way I had posed my schedules and I will let this run. It's fine for me. And yeah, that's all about scheduling. So maybe I will kill this. I will cancel this run as well. I will cancel this run as well. And I will show you that what if I then manually run it. If I just click on this run now, it will be saying launched by manually. Okay. So this is how scheduling works. Cool. Now again, I will cancel this. And I can see in the logs that it is showing the status of run, cancelled, and everything out. And I guess it even will give me the email because I had configured the email. Let me open my Gmail. And you can see, guys, it is throwing the error that did by Databricks that your run has been terminated and your pipeline has failed. Because I had mentioned that if my pipeline is failing, please send me the email as well. Make sense? Perfect. Perfect. That's all about Spark Declarative Pipelines, guys. Please do revise these topics. These are very, very important and these are very future proof topics. Cool. With that said, we had literally covered the complete tutorial, and I really want to congratulate each and every one of you who had reached till this point. I really want to know who had 100% completed this tutorial. Do comment your experience in the comment section. I will love to see those comments. Thank you so much for watching, and let me know what next you want on this channel, and I will love to create that. Thank you. Thank you so much. Do consider subscribing. Have a really nice day. Bye bye.